So I spent some years in extended leave from my university, and when I came back, I wanted to teach some, more modern classes with a larger audience. And my department chair told me, okay, why don't you revamp a web class, teach it, to a more larger audience, about 150 students or so. And by the way, we have only one TA, because the funding these days is have to come by for more TAs. And so I started to think at various elements of it. So which web framework to use, and also how to actually manage the whole class. So one of the things I learned quickly, I knew before doing this, is that when you teach a class, it's not so much about which one framework is the most perfect in absolute, but it's about the logistics. Can students submit the homework? How long is it before they can get something useful done? And how do you organize the sharing of apps and data so that people can actually look at code and have fun with it? Okay, so these are the most important problems in a class. Because in the end, if they learn a framework, most likely when they go to work, they will use another one, right? So the important thing is that they learn the principles. So I fell in love with web2py rather quickly, because a lot of the things that I found boring to do in other ways, I could do them very quickly here. So this is the first example that I gave the last time I taught. So we were making a crazy bulletin board in which people could just enter something for sale or for buy, and then they could edit or delete their own posts and view the post, right? So it's just plain. So this is very, very simple, but all it took me are these lines. This is all it takes to generate that page. So there is one thing for the index that basically defines the conditional buttons. These buttons that you see here on the side, the delete and edit are defined here. Oh, sorry, if I touch here, this goes bonkers, sorry. So the conditional buttons are defined on top, and then I just define a square form grid that essentially defines the grid, and the visual portion are those three small lines at the bottom. So this enables me to do interesting stuff with the students, essentially within the first class, within the first week of classes, and get them started, okay? And the other thing that was essential for me is that web2py is app-based. When you write a new website, it can package it as an app that contains with it also the database and everything you need. So there are these buttons that say pack all. A student presses it, they pack the whole website, including the data, into essentially it's a tar file, but this guy does a file with a funny extension, but it's a single file. So they can upload it, somebody else can download it, they can load it up in web2py, and boom, they're running exactly the same website. And this turned out to be absolutely essential in teaching. It means that a student is in trouble, they can pack their app, send it to me, I can load it up, and they can see exactly what's wrong with their database content. It's simply invaluable in teaching. Of course, there are a few more traps there. The students who are unlucky enough to hit compile run into trouble. But once these small problems, you can steer them around those. I have by now pretty good instructions on how to do submission. So this solved in a beautiful way the number one problem, which is how do you get people to submit and exchange their work, okay? Which is logistic problem number one. The number two issue is how can you grade 150 websites per week or per 10 days? And by the way, I teach an even larger Android development class where I have now 180 students. And Android apps are more unwieldy than web2py apps by a factor of 5 at least. And so, the problem is even multiplied. So how do you manage this huge grading? And I thought, well, I'm officially good at crowdsourcing and game theory, and so I should be able to do something. So I built CrowdGrader, which is a built-in web2py, and it's a site that enables students to grade each other's homework. And if I have to be frank, at the beginning I built it in the sense that I do this, then I hit the beach, they grade their own homework, and I'm fine with it. But in the end, it turned out that the students actually like it. I'll tell you why. So it works in a fairly traditional way. You submit the homework, students review each other's homework. I will tell you exactly how. There is some special thing there. I compute crowd grades, so the grade for the submissions, and then the students get the feedback. So this is all very traditional, okay? And now I want to tell you a little bit more about some things. So I did. One of the things in doing CrowdGrader is, you know, when you get the satisfaction of doing right things you have so often seen wrong. Our university has one of the most horrible systems for managing homework submissions. So at least I wanted to, you know, do things not perfectly, but at least manage to do you know, smooth out all the glitches. So I accept any file size, no limit whatsoever. You can download 5 gigabytes if you want. Students don't do that, because if they get to review a 5 gigabyte size submission by somebody else, so they will give it a low grade, right? So there is an automatic disincentive to uploading to large stuff. But I have classes that use these for movies, and so they can upload their 200 megabyte movies without any problem. So, you know, half a gigabyte occasionally. So there are no limits and no nothing. The only limit is that you can submit only one file, because otherwise reviewers forget to download all the files and they get confused. So it's easier to, you know, force people to zip everything together in a single element, so that things don't get out of place, essentially. Review, the only trick is that you have to assign them one by one. Here we're running a conference. Everybody who has ever run a conference, you know that you assign the work to everybody, then they don't do it. And if they don't do it randomly, there are always pieces that don't get enough reviews. So instead, I don't reallocate reviews to students. There is a button that says, give me the next one, and then I give the next one. And I can dynamically optimize which one I give. I can optimize it regarding the number of reviews and the amount of uncertainty on each piece of homework that is being reviewed, right? And in the long run, I also want to optimize it. I haven't done it yet, but this summer I will work on optimizing it in the sense of, you know, after a short while, you know the abilities of the students. So how do you best match the homework with the ability? Okay, so you can do it if you do it one by one per request. Optimal grade aggregation. So this is something on which we are currently working. One of the hidden goals of CrowdGrader is that, coming back to academia, I didn't have a lot of data to work on for you know, for my reputation systems and crowdsourcing that I do research on. So I thought that, you know, since I'm a faculty, I force students to take classes. That generates free data, hence let's use it. And so I started playing around with these algorithms, and this we call it the Vancouver Algorithm. The idea is super simple, but it's at the basis of what we have now. So essentially, assume that you have some people that give you grades for a single item, okay? If you know nothing about the users, and if you believe that they're equally reliable, the best you can do is take the average, essentially. Now, if I tell you that of each user I know the variance, because I know how precise they have been in the past, what's the optimal way to aggregate grades if you know the variance of each evaluator? Again, you know, this is, you can solve it for yourself. It's a little bit of, you know, simple mathematics of what is the variance of a weighted average, et cetera, and then you can optimize it, but it's well known. And the answer is the minimum variance linear estimator. So you essentially give to each element a weight that is proportional to the inverse of the variance. Intuitively, it makes sense, right? The higher the variance of a person, the less weight you want to give them. And it turns out to be precisely true. Once you have this idea of the minimum variance linear estimator, you do the following. You have items and users. You build a bipartite graph. And then you do the following. Every user sends to each item the grade they gave. The item thinks, OK, I received these grades. I do the average. This is my value, OK? Then you send back all the items that tell all the users. For example, all the items I evaluate tell me, hey, you know, you gave me a 7, but it was a 7.5. You gave me an 8, and there was indeed an 8. You gave me a 6, and no, I'm sorry, it was only a 4. And so every user can compute, not the user, but the code, of course, can compute their own variance, right? You can estimate now the variance of the users once you do this. Now that you have the variance of the users, so the next step in the opposite direction, you can send to the items not only the grade, but also the variance of the user, okay? And so you do a few back and forths. It turns out that if you do too many back and forths, it's a bad idea. The reason is that this idea of using the minimum variance estimator works if the problem is if you are using statistically independent data. If the graph is finite and you do a few back and forths, if you do too many, you're reusing the same nodes too often in the computation. And so the data becomes statistically dependent and your performance goes down. This is a phenomenon known. It's as if, you know, I go 20 generations ago, I should have 2 to the 20 grandparents or 20 parents or something like that, right? But these are not all going to be different people, because there weren't enough people in the world that are in my region of Italy then, right? So a few of them coincide, and so the data is not statistically independent. For the same reason, it doesn't help. The optimal number of iterations experimental is around 3 or 4. But this leads to essentially better grades. So if you do it on a synthetic data, this performs really well, because the synthetic data has an error model that is equal to your error assumption. So depending on how skewed are evaluators in giving grades, depending on what is the distribution of variance among the users, essentially, whether most of them are good but there are some bad, or whether they tend to be more uniformly bad or whatever, you can do between 4 times and 3 times better. But the reality is not so nice. The reality, in reality, we now have data from various classes, because we have also instructor data. As I tell you later, CrowdGrader enables instructors to step in and give grades to some subset of the assignments. And many instructors do it just to keep a tab on the class. And so comparing to instructor data for the harder-to-grade classes like Android, and I believe also web, but I don't have data already on web, we reduce the error by 30%, the standard deviation. For introductory CS classes, the problem is that many students get demoralized if they don't get full grade. So, already the grade distribution is with a lot of top grades. The things are not so hard to grade, and so, yes, CrowdGrader works, but reduces the error by only 10%. What I want to do next with my students is that we are trying to build more sophisticated models of student error, because the students don't really have just a variance when they evaluate. There are typical errors they do. For example, they're more precise at the high end than at the low end of the scale. Or if they don't understand anything, they give a 0 without, trying to figure out harder. So the error model of a student is fairly particular, and we are trying to build a much better match for that. So the biggest cause of error is essentially misunderstandings. So we are doing 2 things on it. First, we allow people to decline a review. There is a limit to how many they can decline, but we let them decline the review if they cannot understand anything. A typical case is, sorry, I cannot open your zip file. I mean, it seems silly, but they do that. Or, or they get confused, and they cannot import the Android app in the right way in their tool. Or, the cases like these have no end. The ways of shooting themselves in the foot is infinite. And so, but at least so they can avoid being nasty to each other. And the other thing we did is that there is, as in various conference management systems, there are these anonymous forums where people can discuss. So the author can say, I'm terribly sorry. I called my main web view, I called it index2 instead of index. Would you please grade that instead? And then the graders can see that and can reply. And so I try as much as possible to let students have the sensation that they're in control, that that their fate does not hang on the misfortune of having made a silly mistake at some point and then being, out of luck on that. So you can also sort all the submissions by average or by delta. Delta is the disagreement on the grades. So what I typically do is this. Now I have 180 students in my Android class. I have this CrowdGrader, and then I tell my TA, please, I cannot show you real data for confidentiality of student data, right? But I usually tell the TA, please go in and can you grade the 15 submissions with the biggest disagreement? So that that keeps essentially a tab on what's happening. Plus, we grade some special cases, but essentially we go from 180 to 15, which is very manageable. Why do students review? Because this is where I put a bit of effort in the math. That is, I want them to have an incentive to review. So the grade depends. For some parts, 75 or sometimes 70% of the submission grade, and 30% or 25%, depending on the class, you can choose on the reviewing process. So you get some points for doing the reviews and for being precise. And you get some of the points because when I do a review, the recipient of the review can give me feedback that goes from -2, which means essentially you are an idiot, or you didn't understand anything, to +2, that means, yeah, thank you, it was really helpful, okay? And so this human feedback plus the precision that is computed automatically, obviously, go towards your review grade. And this is a big enough percentage that actually students do it. And this is, because I have this game theoretic framework, so I'm always the nasty one, I'm afraid, But in fact, this is the helpfulness of the reviews that points to high. And I'm not sure I have a slide on it, but I want to tell you what the biggest advantage is by far of this tool. And I think, well, I talk a lot about grade precision, but we know that it's not the real problem, because in a class you have many assignments. In the long run, separating the good from the less good is not really very hard. The hard thing is to make the class interesting. And so what works really well here is this. You do your assignment in web2py or in Android, and people tell me similar things of what they do. Now, the students now get, especially the ones that don't get it to work well, now they get to view 5 or 6 or 4. Typically, I ask them to grade 5 others. They get to see 5 other solutions that actually work, that are typically written in different ways, and they can go look at all the code. And that really helps. Especially, everybody does this assignment in which now we build the simple part, now we do it a little bit better, now we do it really great. Then we start with another job, and we do it again in 2 installments or so, right? So the people who don't get the first part, they can get to see a lot of examples of how other people did it. And in my class, they have explicitly the permission, they can quote the code they get from others, so they can say, but they have the permission to do it, and it doesn't lower their grade at all. We all code by borrowing, right? So I simply tell them, you do the assignment, but for the next one, if you didn't get yours to work, look at the solutions you grade, and if 5 is not enough, you can grade more if you wish. And so they can really see working examples on how it works. They can get much more feedback. This is actually real feedback. I obscured the name, but this is real feedback on a web app. Okay, so this person got 1, 2, 3, 4, 5 evaluations, and this is all the comments. I cannot think of a TA ever writing so much on a single submission. So in the end, they get more feedback. There is always, people have this belief that the instructors are very reliable in grading. I don't think it's very true, actually. What happens here is that often students find bugs that the instructors don't find because they're in a hurry. Having people look at it from different angles gives you, in the end, often a much more I wouldn't run in this way a class in which people have to prove theorems by induction, because it would be like drunkards trying to lead themselves home in the evening. But for these kind of things, the level at which you can check them is much better than these very theoretical classes. So the instructor also can have access to all the reviews, and actually what we want to build is some better analytics so that you can see like what are the most common errors. But you can go in and you can flip through pages and pages and pages and pages of reviews, and you can chase the student to say, who wrote this stupid thing? Then you can go and see how good their homework was, and you can see what they gave as grades to others, and then you can follow through all these various cycles of things. So you have really pretty good control. Now, since you're all interested in the basis, how did I do this? So web2py has given me a lot of happiness. I wasn't really a very good web developer before I started, right? So that I could pull it off while teaching and doing other stuff is a testament. But I chose to run on the Google Cloud. This I was very happy with it. Basically because Appengine gives me this scalability and very ease of deployment, in which I can just say, oh, upload these and and in 10 seconds is uploaded and run up and running. And it scales up so that when these large classes, I've hosted classes of up to basically 1,000 people. And when I have these very large classes that all have the deadline on a Thursday night, say, the server utilization spikes up, when everybody tries to submit just 1 minute before midnight, and this works well. So I'm very happy with Appengine. It's expensive per CPU minute, but an app like this is very CPU efficient. And I use a bunch of ways to store the data. I was one of the very early users of Google Cloud SQL when it was still in alpha or something like that. And I've been incredibly happy with it, actually. It has worked fantastically, very efficient, very well maintained, and very well backed up, and very well whatever. I use the Google Datastore, but only as a key value store. So the difference is that Google Datastore, I don't know how many of you have used it extensively, it has these 2 remarkable properties. One is that it has essentially infinite read and write bandwidth because it's fully distributed, like a MongoDB that you don't even have to maintain. The other semi-nasty part, though, is that it has a very unusual consistency model. So you have to be careful about transactions. And you know, students don't typically like if their homework is gone into the nothingness of space. And so I basically keep a very dense Google Cloud SQL database in which I just put the metadata. I don't put anything but metadata. And then I put all the text in the Google Datastore with a memcache layer on top of it. And I use the Google Blob Store as the inexpensive storage for all the things that students want to upload. And so, so this data organization works very well. And essentially, the cloud, Google Cloud gives me also these task queues that I use for the heavyweight computation all the time. For example, you know, when I do this statistical model analysis, they sometimes take me some minutes of CPU time, no? And so these I can just put into the task queue, and you know, when the instructor looks at it later on, the models are computed and everything works. So in general, you know, this is something that I'm keeping up alone, essentially, alone and on probably 1/10 of my time. And it has worked with zero downtime. And so I think this is a testament to how well this works for scalability and maintainability. Just something very quick on why I love web2py. This connects also to the DAL talk of this morning. This is essentially a mix between DAL and web2py. I told you that I put the text in the all the text that you type. No, I put it into the Datastore so that to keep the database small. And so that why do I keep the database small? Well, first of all, because once upon a time I was building databases for storing Wikipedia analysis, and I got burnt too often by having these huge databases that were hard to manage in the end. I mean, not to manage, but how to use efficiently. So my theory is always to keep the database as small as possible, so that most of it can be cached in memory, at least the part that you that you care about, right? So now you would believe that it's complicated each time that you have a record that contains many pieces of text to go and assemble it and disassemble it into the various pieces. In reality, it's quite simple. What I do is this: I use the DAL of web2py to define a table in which my field is a text field. And I say that when I represent the text field, when I can it for visual display, I do the following. I have this representation function lambda vr, where v is the field value and r is the row that I don't use. And I say, take the field value v, go to my key value store and read what corresponds to v, which is only the key. Oh, and by the way, put that into MarkMin, which is one of these Wikipedia-like markup language editors, so that you can really write in a rich markup language. And boom, they get this text in markup language that even supports math. And instead, when you have to edit such a field, all I need to do is this. When I process a form, I say on validation, call this function that is called store field, in which I give it the old key. And the function, all it does is this. It defines a form processor that says, my field is equal, so to key val right of the old key and the new field content. So basically, that single line there, which is the only important line there, is replacing the text with the key that results from writing the text to the Datastore. And so this is just an example, right? But I can do all these representation things that keeps essentially my data organized in what I think is a fairly cute and very scalable way. And still my overhead is essentially minimal. Very, very few lines of code that are needed in order to organize the data in this fashion. I think I went too fast in my talk, but this leaves more time for questions. I just wanted, so this CrowdGrader, I started it for these reasons, because I didn't know how to grade, and because I wanted to gather data for my team. Lastly, so I have 5 minutes, but that's fine. I'm not going to talk for 5 minutes about these. So then I made it available to all. It simply runs there on the Google Datastore, so on the Google Cloud. So you can use it yourself if you are interested. We are now, I think this is concluding the first year in which, at the beginning I had some sort of more ragtag system, etc. This concludes the first year in which it has been running in this, in this version, in this hosting with this set of algorithms. And we have had now 40,000 submissions and over 200,000 reviews. The UI is not great because I'm doing it and I'm not really good at UI. By the way, if there is somebody of you that wants to consult for UI, I would be super happy. But while it's not great, I've gotten to the point in which I hardly receive one email of complaint from all these submissions every couple of weeks. So even though I'm usually busy during the day doing other things, this just goes on autopilot. And then the way I develop it is that on some weekends, then I dive in and build some new feature for it. It has been extremely productive as a way of working. So it's there if you want to use it, and thank you very much. So if you have any questions on either the algorithms or the hosting or the use of web2py, I would be more than happy to answer it. Okay, so I see a first question there.
Just a really quick question. Do you randomly review some assignments that are submitted to you, or do you just focus on those with the most significant deltas between the students?
Okay, I'm a little bit lazy, okay? So I'm big to keep my work under control. But what I'm doing this quarter is, because I have so many students, very brutal is this, because I already have to build all the sample code that they work on and yada yada. So I essentially tell the TA, please review the 15 to 20 things on which there is most disagreement. Then anyway, I have to review everything that the complainers complain about, which is 2 or 3 extra. And then aside from that, I basically look at the reviews, okay? So yeah, that's what I do.
Other than writing your basic retrieval logic to assemble your records from your relational database and your key value store, is there any sort of like error, special error handling layer that you have to write for timing differences and retrieval times and that sort of thing, or not really?
No. When I retrieve just a little bit of information, that retrieval layer I showed you is sufficient. The only case when that's not sufficient is when you, for example, you get a page of 20 reviews. If I do the simple thing, then you would be doing 20 sequential queries to the Datastore, which works perfectly, but it's inefficient. So what I do in that case is, for those places that are critical bottlenecks, at that point I gather. First, I gather all the keys. Then I do a parallel read on the Datastore, on which you can do a parallel read, and then I fill in all the holes, and then I present it. And there I can shave a considerable amount of data. And it is because of this that actually, to talk to the Google Datastore, I tend never to use the excellent but somewhat simplistic regarding the Google Datastore, how it is called, the web2py database layer. I generally brew my own. Because essentially the database how it is called? PyDB, PyDAL. PyDAL is incredibly good for SQL-based databases. But when you go to things like Google Datastore, it pays to pay. You have this parallel model of accessing data in which you can send at the same time 50 keys, and then you can retrieve them at the same time and at the speed of the slowest to be retrieved. So these things pay out a lot, and so I do it.
Is the source code freely available online?
So the source code of the algorithm I described is available. The source code of an early version of the tool is available. The source code of the current version of the tool is not available. But the tool is free. So, yeah. So essentially, this was, it was developed at the university, but then I took it as a small startup. The startup is not making any money, but at least, I wanted, it protects me from being sued, I guess, is the answer. No, but at least I can get the money in and get the money out of an account that is not my personal wallet. Any other question? Okay, thank you.